So, you've probably heard the term project-based learning, right? PBL. It's one of the biggest buzzwords in education today. But what really separates a project that's just a fun activity from one that creates truly deep, lasting learning? Well, the answer comes down to one powerful ingredient, something called sustained inquiry. You know the feeling, your kid comes home all excited about some huge multi-week project they're starting. And as a parent, there's always that little voice in the back of your head wondering, are they actually learning anything? Or are they just, playing around instead of doing real schoolwork? It's a fair question, and we're going to get to the bottom of it. Because that line between just playing around and some of the most profound learning a student can experience, it all comes down to this one secret ingredient: sustained inquiry. This is what gives project-based learning its real academic muscle.
So, what is it exactly? Well, put simply, it's a rigorous, extended process of asking questions, finding resources, and then applying that information. And look, the keywords there are rigorous and extended. We are not talking about a quick Google search for a fact. We're talking about a deep dive, something that happens over weeks, where students are in this constant loop of questioning, searching, and actually using what they find.
Let's make this super concrete. A traditional assignment might be, hey, write a report about renewable energy. Okay, straightforward enough. But a sustained inquiry challenge, that sounds more like design an energy solution for our school. Whoa, that is a whole different ballgame. All of a sudden, you have to ask a million new questions. What's our school's actual energy usage? What's our budget? What are the local building codes? Does our roof even support solar panels? See, there's no single right answer to find in a book. You have to go out and create one. And that reveals something absolutely crucial about this process. It is not a straight line. It's not A to B to C. It's a cycle. You ask a question, you go find some information. And that new information doesn't just give you an answer. It sparks three more, even better questions. And that cycle looks something like this. Students start with these big initial questions, but as soon as they find resources and try to apply that information, they immediately run into things they don't know. And that discovery, it leads to new, much smarter questions. They refine, they repeat, and it's this constant iterative loop that builds a truly deep and flexible understanding, not just some superficial knowledge. Okay, so the theory sounds fantastic, right? But does it actually work? I mean, is there any hard evidence that this whole method produces better results than traditional teaching? Let's take a look at the data. A recent, massive meta-analysis pulled together dozens of studies on this kind of learning, and it found that the impact on students' critical thinking skills could be measured with a single, stunning number: 1.27. So what on earth does a number like that actually mean? Well, in educational research, an effect size of zero point 0.2 is, well, it's pretty small. An effect size of zero point 0.8 is considered large. That's a big deal. An intervention with that effect size gets people really excited. So an effect size of 1.27, that is absolutely massive. It's a gigantic, practically meaningful leap in a student's ability to analyze, to evaluate, to connect ideas. The data couldn't be clearer. This stuff really, really works. So we have this incredibly powerful method for building critical thinking. But what happens when you pour rocket fuel on it? Because that's exactly what artificial intelligence is doing for sustained inquiry. We're not just talking about a little upgrade here. We are talking about a fundamental transformation of what's even possible in a classroom. And honestly, it's incredible. Don't just take my word for it. As researcher Phil Alcock puts it, when students can partner with AI as a tool, they can suddenly tackle problems with a level of complexity and produce work with a sophistication that frankly was unthinkable in K-12 education until right now. So how does this actually work? Look, it's not about asking the AI for the answer. That's not inquiry. That's cheating. It's about using it as a super-powered partner. Think about that school energy project. Now, students can use AI to analyze decades of local weather data in seconds, to simulate the cost-effectiveness of 10 different solar panel designs, or to identify complex patterns in the school's energy usage. The AI becomes this tireless, brilliant research assistant, helping students think bigger, deeper, and faster. And let's be really clear here. This is not about shortcuts. This is not about making schoolwork easier. It's about amplifying the rigor. It's giving students the power to engage in the kind of complex analysis and problem solving that, until very recently, was pretty much reserved for professional researchers and engineers. A powerful teaching method, now supercharged by AI. This all sounds amazing, but what does it actually take to make it happen in a real school?
with real teachers and real students?
Well, first, the teacher's role has to change a lot. One researcher described it perfectly. They said traditional lesson planning is like a fixed train schedule. Week 4 is fractions, week 5 is decimals, no matter what. But in this model, planning is more like having all the pieces of a jigsaw puzzle. The teacher's job is to deploy the right piece, the right mini lesson, the right resource at the exact moment students need it, based on the questions they're asking right now. Now, making that shift is not simple. Research is pretty clear that for this to truly take root, it can't be a one-off thing. It requires a deep, long-term commitment from the whole school. That means serious professional development for teachers, flexible schedules that actually allow for this kind of deep work, and, of course, new ways of assessing students that go way beyond a multiple-choice test. So when you put all of this together, the method, the data, the AI supercharger, you start to realize that sustained inquiry isn't just another teaching strategy. It really represents a fundamental shift in what we even think learning is, and maybe what schools are for.
Here's the core of it. The traditional model, a lot of the time, positions students as passive receivers of information that already exists, right? They absorb it from a teacher or a textbook, and they prove they learned it by repeating it on a test. Sustained inquiry completely flips that. It positions students as active explorers, as creators of knowledge, who are tackling real, messy problems that don't have an answer in the back of the book.
The world our kids are growing up in is not a multiple choice test. It's defined by incredibly complex, messy, ambiguous problems that demand creative, collaborative solutions. So that brings us to the final ultimate question. What is the true purpose of school? Is it to prepare students for a world of known answers, or is it to empower them for a world of complex questions? Because all the evidence suggests that sustained inquiry is our very best path to doing the latter.